In this last question, we have a Maclaurin series. And the series, we need to find the series for e to the x sine x. And we have both of those functions in our formula booklet. So we can just simply multiply these two together. We have 1 plus x squared over 2 factorial times x minus x cubed over 3 factorial. We don't need x to the power of 5 because we only need to go up to x cubed term. So when we multiply this, we do 1 times all this. Let's write that as 6 now. And then we have x times x squared. X times this gives you x to the power of 4 actually, so it's too big. We don't even need that one. And lastly, we have x squared over 2 times x is x cubed over 2. And that's all we need. Let's simplify. X plus x squared. This is negative x cubed over 6 plus 3x cubed over 6. So when we add it together, we get x plus x squared. That's going to give you 2x cubed over 6, or just 1/3 x cubed. So that's the Maclaurin series. And the next one, it says, hence, find an approximate value for this integral. So notice this is e to the x squared sine x squared. So we have to plug in x squared into this function. So it's the same as, or it's approximately equal to the integral of 0 to 1. Substitute x squared into this Maclaurin series. We have x squared plus x to the power of 4 plus 1/3 x to the power of 6 dx. So let's find that integral. We get 1/3 x cubed plus 1/5 x to the power of 5 plus this becomes x to the power of 7, and we divide by 7, so we're going to get a 1/21. Okay, we need to do that, evaluate it from 0 to 1. So you plug in 1 to all of this, you just get 1/3 plus 1/5 plus 1/21, which we have to add together and get a common denominator. Common denominator is going to be 5 times 21, 105. So this is 5 over 105. This is 21 over 105. And this is 35. So your answer is 61 over 105. In this next part, we're going to show that g of x satisfies this equation here. And what that means is basically that this equation is true. Okay, so we need to show that this equation is true. So we need to obviously find the first derivative and the second derivative. So let's do that first. The first derivative, so remember our function is e to the x cosine x. Okay, e to the x cosine x. So the first derivative, we have to use product rule. The derivative of e to the x is just e to the x. That was easy. And the derivative of cosine is actually negative sine. So let's do negative e to the x sine x. And next, second derivative. Okay, so then we have derivative of this again, which is, we already know what the derivative of that is. It is this. And then we find the derivative of this. And derivative of sine is cosine. So do we get something to cancel here? The cosines cancel, and we got negative 2 e to the x sine x. Okay, so now let's do 2 times g prime of x minus g of x. So that is 2 times e to the x cosine x minus e to the x sine x. I didn't mean to close that bracket. Minus g of x. Minus g of x is e to the x cosine x, which equals, we get negative 2 e to the x sine x, which equals g prime, double prime of x, as required, as the question required. This next part, we have hence deduce that the fourth derivative equals this And it's only worth 1 point actually, so there's not much work required. You can go through the same procedure and find the third derivative and then the fourth derivative, and then it'll be equal. But just note that what we have from before, let's write down what we had from before. We had the second derivative equals twice the first derivative minus g of x. So you can just simply differentiate both sides of the equation. So the derivative of this is this, right? And we just do that one more time. Fourth derivative equals 2 times third derivative minus second derivative as required. Okay, so if you do it the other way, you'll spend a lot of time. This is pretty quick. So just find the derivative a couple of times. Next in part D, we are using the result from part C to find a Maclaurin series of g of x up to including the x to the power 4 term. So the most common mistake for this kind of question is people use another method. It says using the result from part C. You cannot use any other method even though they're correct and they'll give you the correct answer. You will get no points for it. So you have to use part C. So you have to use this kind of thing, right? So here's the formula from the formula in the booklet for a Maclaurin series. And so what we need to do is we need to find g of 0 and g prime of 0 and g double prime of 0. And then we can have the Maclaurin series. So g of 0 equals, let's remind ourselves what g is. G is e to the x cosine x. So that's e to the 0 cosine 0, which equals 1, right? Cosine 0 is 1. G prime of 0 is in part, so we worked out the first derivative already. It's 0, e to the 0 cosine 0 plus, what was that, minus e to the 0 sine 0, but sine 0 is just 0, so this part's irrelevant. And we have a 1. Now g prime of 0, we got to use the result from part C. We have, it's 2 times, it's pretty easy actually to subtract these values. So we have 1 minus 1, which equals 0. And g triple prime 0 is 2 times the previous two ones. Look. So that's going to be negative 2. And g fourth derivative 0 is going to be 2 minus the previous, subtract these two, right? And we have, that's going to be negative 4. So that means the Maclaurin series is f of 0, so that's just 1 plus x plus x squared over 2 times 0 plus the next one is x cubed over 3 factorial times negative 2, and the last one is going to be 4 factorial times negative 4. So it's going to be 1 plus x plus half, oh that's 0. This is going to be minus 1/3 x cubed, and this is going to be minus 1/6 x to the power 4. In this last question, we have hence or otherwise determine the value of this limit. So you can do it any method you want. Hence is usually easier. The otherwise, in this case, you could do L'Hopital's rule like 3 times. But the hence is easier because we can just plug this in for e cosine x, right? So this is going to be equal to the limit as x tends to 0. Just plug that in. We got 1 plus x minus 1/3 x cubed. Let me erase that. That's a minus 1/6 x to the power 4 dot 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 minus 1 over 1 minus x over x cubed. So let's simplify a bit. And this 1 plus x and this 1 minus x cancel, and we have negative 1/3 x cubed minus 1/6 x to the power 4, and then some higher order terms over x cubed. And then x cubed will cancel with this, and it'll cancel here to give you 1, and it'll cancel a bunch of other things here that we can't see, but they're there. But the only thing that matters is this first one, so we're going to have negative 1/3 minus 1/6 x dot 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 higher order powers of x. Okay, so at this point we can plug in 0 for x, and we get just negative 1/3 is the limit.